Chapter 9, Number 37. The collision between a hammer and a nail can be considered to be approximately elastic. Calculate the kinetic energy acquired by a 7.2 gram nail when it is struck by a 450 gram hammer moving with an initial speed of 8.8 meters per second. So we're really just going to steal some formulas from the book on elasticity because those formulas are complicated and you're not expected to know them offhand. As usual, we should have a picture. So we have the hammer head coming down and we have the nail going to be struck, and the hammer head will say has mass m1 and velocity v initial, and then after the collision the hammer head, let's say that it keeps moving forward with v1 and the nail is driven downward with speed v2 and it has mass m2. These are just to accord with the setup from the formula in the book, which tells us that the final velocity is going to be the difference in masses, so m1 minus m2 over their sum, m1 plus m2, times the initial speed coming in. And from the problem we have that it is a 450 gram hammer hitting a 7.2 gram nail, and then we have 450 gram plus on the 7.2 on the bottom, times 8.8 meters per second. And this turns out to be 8.52 meters per second. I'm going to carry an extra sig fig until the very end. Also notice that we didn't actually have to convert the masses because they're in ratio, so the conversion factor would cancel out. Along the same lines, we have from our textbook that V2 is going to be twice the original mass over the sum of the masses, all times the inbound speed. So twice 450 grams over 450 grams plus 7.2 grams times 8.8 meters per second. And this is 17.3 meters per second, so almost twice as fast. Actually, somewhat more than twice as fast. All right. Sadly, that is actually not what they asked for. What they asked for was the kinetic energy. And they say acquired by the 7.2 gram nail, so we assume that that is just, all they care about for that is the energy of the nail at the end. So the kinetic energy that they're worried about, it started at 0, so what it acquires is just its end. And that's 1/2 times, and now kind of we do have to say this times 1 kilogram per 1,000 grams because we're going to want to get it in joules. And we ended up at 17.3 meters per second quantity squared, and that number is 1.077 joules, which for our two sig figs is really 1.1 joules. For all that work and a relatively high speed, we don't actually get a whole lot of energy out, but that's largely because the mass is so small.